Steering a large articulating tractor applications is not always an easy job. Well, Case IH has an optional steering system for the 9110 and 9130 series tractors that will make steering easy. Combination steering. Combination steering combines articulation steering with front axle steering. With this steering system, the operator has a choice between articulation-only steering or combination steering. Combination steering provides the operator with precise turning control in row crop applications and an overall tighter turning radius. This program will explain the operation and the components of the Case IH 9100 series articulation steering system. We'll then cover the combination steering system and how it works in conjunction with the articulation steering system. Finally, we will assist you in determining if a steering problem exists and what to do to correct the problem. The articulation steering system in the 9100 series tractors is completely hydraulic. It consists of four main components: the main pump, a priority valve, an orbital steering pump, and the articulation steering cylinders. The main pump supplies oil to the priority valve, which gives the steering system first demand of the hydraulic fluid. The hydraulic fluid not being used for steering is available for the implement hydraulic system. The priority flow from the priority valve is then directed to the orbital steering control valve. This valve is connected to the steering wheel. When the steering wheel is turned, a rotary valve directs the oil flow to the steering cylinders for articulation. So the components in the articulation steering system are the hydraulic pump to supply the oil, the priority valve which gives the steering system first demand of the fluid, and the steering control valve which directs the fluid to the cylinders for steering. Now let's take a look at the combination steering system and how it operates with the articulation steering system. The combination steering system allows the operator to steer the front axle 6 degrees to the left or right before the tractor articulates. A two-position rocker switch, located in the cab, switches the tractor from the articulation-only steer mode to the combination steer mode. When this rocker switch is placed in the combination steer mode, an electrical signal is applied to another hydraulic valve, a solenoid-energized double selector valve. The function of this valve is to direct oil flow to either the front steering cylinder or to the articulation steering cylinders. When the solenoid on this valve is energized, the control spool moves, directing the oil flow from the steering control valve to the front steer cylinder. This allows front axle steering. When the rocker switch is returned to the articulation-only steer mode, the electrical signal is no longer applied to the solenoid on the double selector valve, and spring pressure brings the control spool back to its home position. This directs the oil flow to the articulation cylinders. In the combination steering mode, when the front axle has reached either of the 6-degree steering extremes, the electrical signal to the solenoid on the double selector valve must be removed. This directs the oil flow to the articulation cylinders to continue steering in the correct direction. To control the double selector valve, a microprocessor is used. But before the microprocessor can control the double selector valve, it must know the position of the front axle and the articulation joint. This is accomplished with the steering system's electrical components. The components that make up the electrical part of the combination steering system are the microprocessor, a front axle position sensor, an articulation joint position sensor, and the rocker switch. The microprocessor in the combination steering system electrically monitors the position of the front axle and the articulation joint. It receives signals from position sensors. These sensors are potentiometers or variable resistors. Potentiometers change an electrical signal when rotated. These potentiometers are locked to the front axle and articulation joint and rotate proportionally as the axle turns or the articulation joint pivots. In the combination steering mode, the microprocessor senses when the front axle has turned 6 degrees from straight ahead. It then removes the electrical signal from the solenoid of the double selector valve. This directs the oil flow to the articulation cylinders to provide tighter turns through articulation. In order for the microprocessor to know when to energize the double selector valve to switch the oil flow from the front steer cylinder to the articulation cylinders, 3 electrical signals from different steering positions must be stored in its memory. The first signal is articulation center. This is the voltage received from the articulation potentiometer when the tractor is at the straight-ahead position. The second signal stored in memory is front axle extreme left steer. This is the voltage received from the front axle potentiometer when the axle is at the 6-degree extreme left position. The third signal stored in the memory is front axle extreme right steer. This is the voltage received from the front axle potentiometer when the axle is at the 6-degree right steer position. As the front axle is turned to the extreme 6-degree right position, the microprocessor recognizes that the electrical signal stored in its memory for extreme front axle right steer matches the voltage from the front steer potentiometer. The microprocessor then removes the electrical signal from the solenoid on the hydraulic double selector valve, and spring pressure returns the control spool to its home position. This directs the oil flow from the steering control valve to the articulation cylinders to articulate the tractor in the correct direction. When the operator steers the tractor in the opposite direction, it will articulate until the microprocessor senses that the voltage from the articulation potentiometer matches the electrical signal stored in memory for articulation center. The microprocessor then supplies an electrical signal to the solenoid on the double selector valve to move the spool to direct the oil flow back to the front steering cylinder to allow front axle steering. The operator will have front axle steering until either of the 2 front axle extreme steer voltages are sensed by the microprocessor, thus placing the tractor back into an articulation steering mode. To keep the articulation joint at a centered position while the operator steers the front axle 6 degrees from straight ahead, a hydraulic makeup valve is used. This valve is actually 3 solenoid-activated valves in one: left articulation, which brings the articulation joint left, right articulation, which brings the articulation joint right, and load sensing, which is always energized along with the directional solenoids. Load sensing signals the hydraulic system to supply the needed oil pressure to bring the articulation joint back to center. These 3 valves are energized by the microprocessor only, not the operator. If the voltage value from the articulation potentiometer is lower than the value stored in memory, the right solenoid and the load sensing solenoid on the makeup valve will be energized to bring the articulation joint back to center. If the voltage value from the articulation potentiometer is higher than the value stored in memory, the left solenoid and the load sensing solenoid on the makeup valve will be energized to bring the articulation joint back to center. This will keep the tractor frame straight when the operator is using front axle steer to make minor steering adjustments. Another feature of the combination steering system is crab steer. Crab steer gives the tractor more stability when working on hillsides and keeps the implement from sliding down the hill. The operator can turn the front axle towards the incline of the hill while in the combination steer mode, and lock it in position by using the rocker switch to put the tractor in the articulation-only steer mode. The front axle locks in position because the electrical signal at the solenoid on the double selector valve has been removed. This returns the control spool to its home position, stopping the flow of oil to the front steer cylinder and directing it to the articulation cylinders. The operator can then articulate the tractor frame to angle the rear wheels up the hill for crab steering. If crab steering is not needed, the operator must place the rocker switch into the combination steering mode and position the front axle straight ahead using the axle-to-frame marker on the turntable of the front axle. Then switch back into articulation-only steering. This will lock the front axle at the straight-ahead position. Then the tractor will correctly steer by articulation. If the steering system does not operate correctly, it will have to be checked. Before beginning, always avoid any possibility of injury or accident. Make sure that the area you are working in is clear of any persons and obstacles, and provide adequate room to perform full left and right turns. To verify if a combination steer problem exists, it will be possible to obtain full 6-degree front axle steer in one direction before the tractor articulates. However, it will be less in the opposite direction. To check front axle steering, turn the front axle to the straight-ahead position as indicated by the axle-to-frame marker. Place a T-square on the turntable of the front axle and mark the turntable and the frame to indicate the front axle's straight-ahead position. Steer the front axle to one 6-degree extreme and place the T-square on the center mark previously made on the turntable and mark the frame at that extreme. Now steer the front axle to the opposite extreme and mark the frame at that position. Measure the distance from the center mark on the frame to both of the extreme front axle steer marks. If the distance between each mark to the center mark is equal in both directions, plus or minus 1/8 of an inch, there will be no need to adjust the front axle potentiometer in the system. If these measurements are not equal within 1/8 of an inch, you will have to adjust the front steering potentiometer and calibrate the system. To adjust the front steering potentiometer, first start the engine and move the front axle to the straight-ahead steer position, as indicated by the axle-to-frame marker. To keep the front axle in a straight-ahead position, install a 3/4 inch bolt through the steering plates in the hole provided in the front side of the turntable. Be sure to remove this bolt after the adjustments have been made. The front steering potentiometer is located on the right side of the tractor, below the exhaust. To view this procedure properly, a cutaway of the front steering system will be used. All the checks on the cutaway will be identical to the checks performed on the tractor. With the front axle at the straight-ahead position, adjust the front steer potentiometer actuation lever link to 3 9/16 inches between the center lines of the rod ball sockets. Remove the cover cap screws and cover from the potentiometer. Make up a test harness using a Packard WeatherPack 3-terminal connector. You can order this connector from your local parts depot. The part number is 35-1692T91. Strip a section of each wire and install the connector in the system. This will ease the taking of electrical measurements. Use a digital volt ohm meter to measure the overall resistance between the two outside wires coming out of the potentiometer. The resistance value should be 1,000 ohms plus or minus 100 ohms. This is the resistance value across the entire potentiometer. The center wire of the potentiometer is the sense wire connected to the wiper inside the potentiometer. This wiper determines the amount of resistance produced as the potentiometer is adjusted. The potentiometer must be adjusted to its electrical center to reduce the chance of being rotated out of its working range as the front axle is turned. This would send false information to the microprocessor, causing incorrect steering. This front axle position sensing potentiometer has a working range of 60 degrees. To determine if measurements are being taken within the working range of the potentiometer, loosen the lock nut on the stem of the potentiometer. This will allow the potentiometer to be adjusted. Attach one of the volt ohm meter test leads to the center sense wire coming out of the potentiometer and rotate its body until a smooth increase or decrease of resistance values are found. That will be within the working range of the potentiometer. Alternate the volt ohm meter test lead between the two outside wires and carefully rotate the body until both resistance values are within 10 ohms of each other. Once the potentiometer has been electrically centered, tighten down the lock nut on the stem of the potentiometer securely to keep it from rotating out of adjustment. Disconnect the test harness from the system and reinstall the cover and cap screws. Once the front potentiometer has been adjusted to center, the frame articulation potentiometer will also need to be checked for proper centering. To adjust the articulation potentiometer, the tractor must be in a straight-ahead position. To verify no articulation, measure the front to rear axle distances on each side. If these distances differ, articulate the tractor until they are equal. This will assure that the tractor is not articulated. Always shut down the engine and apply the park brake before working in the center area where the tractor articulates. There are pinch points that can cause serious injury. The articulation joint position sensing potentiometer is located on the right side of the tractor above the articulation joint. Remove the protective cover and disconnect the potentiometer from the system. Then install the test harness to ease the taking of electrical measurements. Loosen the lock nut on the stem of the potentiometer to allow for adjustment. Using the identical procedure for front axle potentiometer adjustment, find the working range of the potentiometer by measuring the resistance across one of the potentiometer's outside wires and the center sense wire. Rotate the body of the potentiometer until a smooth increase or decrease of resistance values are found. This potentiometer has a working range of only 20 degrees. Therefore, small rotations of the body will help find a smooth increase or decrease in resistance values. This will be its working range. Alternate the volt-ohm meter test lead between the two outside wires and carefully rotate the body until both resistance values are within 10 ohms of each other. This will be near the exact electrical center of the potentiometer. Tighten the lock nut on the stem securely to keep the potentiometer from rotating out of adjustment. Remove the test harness and reconnect the potentiometer into the system. Then, replace the protective cover. Now that the front axle and the articulation joint position sensing potentiometers have been adjusted to center, the steering system must be calibrated. Calibration is the procedure used to store the three electrical signals from the position sensing potentiometers in the memory of the microprocessor. First, articulation center, then extreme front axle left steer, and finally extreme front axle right steer. To begin calibration, remove the 3/4 inch bolt from the front axle turntable used for front axle potentiometer centering. Enter the cab and place the rocker switch in the combination steer mode. Now remove the right side console cover next to the operator's seat. The microprocessor for the combination steering system is located to the left of the Run Calibrate switch under the console. If there's any problem in the electrical system, a red LED will light in the status window of the microprocessor. A green LED indicates the electrical system is functioning normally. With the key switch in the off position, select the calibration mode on the calibration switch located at the right rear corner of the console. Now, start the engine and observe that the calibration light illuminates. This indicates that the microprocessor is receiving an acceptable electrical signal from the articulation position sensing potentiometer. With the calibration light on, momentarily depress the calibration button. The calibration light will go out, indicating that the microprocessor has stored the voltage value for articulation center in its memory. This is the first of the 3 voltage values stored in memory for proper steering control. Steer the front axle to the left until the axle is at the maximum left steer position. Observe that the calibration light comes on, indicating that the microprocessor is receiving an acceptable electrical signal for the front axle extreme left position. Momentarily depress the calibration button. The calibration light will go out, indicating that the microprocessor has stored the electrical value for the left steer position, the second of the 3 voltage values needed for proper steering control. Next, steer to the right until the steerable axle is at the maximum right steer position. Observe that the calibration light comes on, indicating that the microprocessor is receiving an acceptable electrical signal for the front axle extreme right position. Momentarily depress the calibration button. The calibration light will go out, indicating that the microprocessor has stored the electrical value for the extreme right steer position in its memory, the final voltage value the microprocessor needs for proper steering control. Turn the key switch off to remove power to the system. This will lock the values into the microprocessor's memory. If the key switch is not turned off, the system will need to be calibrated again. Now, check the steering system. Select the run position on the Run Calibrate switch. Start the engine and check for equal front axle steer in each direction using the T-square method described earlier. The optional front axle steering system in the Case IH 9110 and 9130 series tractors provides precise steering control. The operator has the option to steer with articulation, combination, or crab steering. Minor steering adjustments can be made to give more steering control in row crop applications. And it provides an overall tighter turning radius, while crab steer assists in steering control on hillsides. This steering system involves electronic components interacting with hydraulic components. These components that make up the steering system require proper adjustment and calibration to work together correctly. Once the steering system has been adjusted, the tractor will give the operator precision steering control for the seasons ahead.